Yeah, hi everybody. Welcome to the lesson number 5 Q&A Zoom meeting. We're going to be looking at one of the more challenging lessons with the course, and it's lesson number 5. It's one we're going to look at water, and in particular, we're going to really look at our micro watershed work and how to go about that, and why it might be an important thing to consider when you're designing. And yeah, so let's get into that. I'll just maybe what I'll do is I'll just share my screen here. We'll look at the assignment, and then we can have a chat about that and maybe do a few practice runs. So let's just get that screen shared. There we go. All right. So we are into lesson 5, of course. And the main event here, we're going to really focus on it. So here you can see we've got a water survey, and that's pretty straightforward. We just want to sort of dial into where your water source originates and your wastewater, where that goes. So that's an interesting exercise, but of course it's only worth 4 points. And then we get into the real tough part, which is the watershed mapping, and in particular the micro watershed. So I know a lot of you have contour information on your base plans, but in this exercise we'll have to zoom out a little bit and try and get information outside of the project site, just to see how these outside areas influence your site. So we'll go through that. We've got lots of time to play with that. The last section is the site water flow analysis, which it's worth more points, but I think this would be quite a bit easier. There's a little bit more mapping, and we're going to talk about sort of the outcome of this process, where basically at the end of the assignment here, we've determined where our potable water comes from, where our wastewater goes, and then we're going to have sort of a big picture macro watershed, which is quite easy to locate online. And then we're going to, again, look at that micro watershed and then look at the site itself and look at how water moves within the site and off some impervious surfaces. And it's not in the lesson here, but what I would encourage everybody to do is to consider the next step with water, like with all the knowledge that you're going to gain from this lesson about your project site. What are your thoughts in terms of how you can best utilize this water? And so we'll go through all these things and certainly answer any questions anybody has. I'll get my chat going here so I can keep my eye on that. So if anybody has questions as we go, I have placed the our Q&A Google Doc link in the chat. But if you have questions, you can just either unmute or pop it in the chat there, whatever you prefer. So no problem looking at everybody's questions here. So okay, so I think that gives us a bit of an outline. We have some resources here, and these are really useful. They're showing us what we're asking for in terms of the graphical end of things. So we want to graphically see a boundary, a basin, and we want some indication of how water flows through the site. It might be quite obvious. And a lot of times the topographic information can help us with that. And then there's some other useful how-to videos here. So there's no shortage of resources on this exercise, as you can see, and for good reason. Again, it's one of those things. Even when I started as an instructor with OSU, I think it was like 7 years ago. This was a little bit tricky to grasp, and so try not to get frustrated if it's not clicking for you. We'll go through and we'll do a couple of sort of demos here, and if for some reason you want, if you want me to use your project site as one of the examples, just put your address in the chat here, and we'll do a couple of them. So I won't be able to do everybody's, but we can certainly look at a few. So feel free to throw that into the chat. We will do that shortly here. So again, we have our rubric. So this, again, it's important to consider because we want to make sure we include all of these items in your assignment, because this, again, is what I use to provide you with some grading. And again, it's fairly straightforward. It's a pretty big assignment. So you can see it's worth 24 points. And again, it's an important piece in the permaculture design sequence. So we really want you to have as much of a grasp on this as possible. All right, so if we look at the template file here, I'll get to that section. So again, the water survey, pretty straightforward. We just want to know drinking water, wastewater, and if you have some graphics or any information about that, that's great. If you're on a well, maybe you have a little bit of info on the gallon per minute, the flow rate on the well, the depth, that sort of thing. So that would be useful. You don't have to include that, but be a good idea. And then, of course, we want your annual average rainfall, as well as the roofing material. So this is where we get into the reality of what can we do with the water coming off project site's roof, and the type of material will determine in a lot of ways what we can do with it. So quite often, if you're in an urban area, you probably have asphalt shingle or something similar, and that does really dictate what the end use of the water is going to be. So, but we'll go over that. And then, of course, you got your SWOT analysis. So what's your sort of takeaways from that exercise? And then we get into the trickier part here, where we are looking at your watershed. And this is a little bit misleading. This is actually the micro watershed practice sheet. The next will be the macro, the big picture. But this is where we are looking. I'll just get my pen going here. So this is where we're looking at, say, your project site. And we are looking at a contour map and trying to determine if we're having, for instance, a high rain event and there's runoff, whether your site is going to receive runoff from any other adjacent properties, or you may be in a situation, and it does happen, maybe your project site is on top of a ridge or a high point, and there's no water coming onto your site from any adjacent boundaries. So it's a very interesting process to go through, and I can show you an example a little bit later of a project we were involved with. And what it really helps going through this process is just to try and crystal ball how your project site might be affected when we're in a high rain event. So let's say it's we're June and you're starting a project. Visually you may not, the project site might look pretty dry and well drained, and you may not see anything to be concerned about. But if we go fast forward into our typical Pacific Northwest winter and we have some extreme rain events, all of a sudden you may find that that applies a bit of pressure onto your project site, and that may be something you want to look at as an asset, or you may have to try and implement some stormwater management strategies to ensure that that doesn't have a negative effect on either a house that's there, or perhaps you put in some retaining walls or that sort of thing. That has happened to us where a retaining wall went in, and winter storm event had an effect on it, not because we didn't foresee that water being an issue, but more so that the mason we were working with made an error. But it was interesting to go through because it was easily rectified, and there was no harm done other than Mason had to undo some of his work. But I'll try and get some photos of that to show a little bit later. Whoops. All right, let's get out of that. Okay, so I see there's a few addresses here. Great, thank you very much for those. So a couple of things. As you know, I've talked about Contour Map Creator way back when we were doing base plans. And although it's not accurate, like it's not accurate enough to use for a client, for a project, in my opinion. But that's what we're going to use today. And that may be what you need to use in this lesson, because it might be tricky to find contours outside of your project site. So there are a few ways you can do that, and we have discussed that in way back in lesson number 2. So again, we're going to use the Contour Map Creator, and this is not normally what I would suggest, but it is a lot easier. It's really good for this course. It's a quick and easy access to some contours. And the reason it's not accurate, just to let you know, is that we have this linked with Google Earth. Oh, it's a little too big. Well, that'll work. We have this link with Google Earth, which the public version is very coarse contour data. So it's like 10-meter contours. It's very unrefined. We'll say that. So again, great for this exercise. Not the best thing to use with a given project. And we can certainly talk about other areas to find good contour data if anybody has a question about that. So first thing we're going to do is look at Matt's address here, his project site. So it's on Walton Road. So I am, now the tricky part is I don't have Matt's work in front of me, and I don't need to. Matt, do you mind unmuting yourself and just sort of guiding me a little bit as to exactly what your project site is here? I'm assuming it might be right here. Is that correct?
Yeah, that's the primary residence, and then there's a barn that's also part of the residents. And the land extends over that little creek.
Yeah.
Up, you can see the property line there, pretty clearly defined. Yep.
Okay, perfect. Thank you for that. So first step in our process here is giving the contour map creator some parameters. So what we're going to do is we're going to tell it what we want. And the first thing is I'd like to have all of the contours in feet versus meters. And I recommend you do level intervals so they're all the same contours. They're not erratic. So on a site like this, maybe we'll ask for 2-foot contours. And I'm just going to move this a little bit. So we're going to start in this position, and I might have to move it because we're not just trying to get, well, maybe that's how we'll start. So if I click on the upper left and lower right, I get a box to define where I want contours. Let us just ask it to get data there. Okay, so it has zoomed in a little bit. Okay, let's ask it to go out a little bit just to see if we get anything interesting here. So it looks like we have sort of a high point over on this side. Now, the one thing we have to keep in mind, which can be tricky, and this is true for both urban and acreage settings, are these roads, right? So these are paved areas that inherently are going to have some form of drainage. So they're either going to be crowned and send the water off into a roadside ditch, or in an urban setting, they're more likely to have a curb and the water is going to go into a catch basin and into a stormwater system. So what I generally do is stay within these constraints. So I'm not going to really be looking beyond. I'm going to get my other pen tool here. Sorry. I'm not going to be looking beyond those roads at this time. Now, if you have intimate knowledge of the site, you might say, hey, I've got, I know that, there we go. You might say, hey, oh, I know there's a culvert that goes under the road here and water comes through the culvert in this direction, and my property picks that up. So that may be the case, and that's great info to have. And that does change the way you would go about this. But for the most part, these roads are a constraint, and we're going to sort of honor them. Okay, so the first step that we're going to do here is put in our property boundary. So I'm just going to do a very rough property boundary. And it looks like I'm a little too high up to the north here. So I just have to shift a bit. Uh-oh. There we go. All right. Yeah, with this exercise, with using contour map creator, you do have to kind of get yourself into position, well, especially on with this tool. Otherwise, if I move it, that's not too bad. Actually, that's gonna do us. Let me just get property boundary tool going here. So let us assume we're going to do straight lines. So we'll say that's a boundary, and it looks like yeah, it looks like that's a boundary. I might not be getting this totally accurate. Looks like it might go this way. Is that right, Matt? Does that look right? Or are you more straight up here?
It's straight up
Okay.
from that. Yep.
I know this isn't totally spot on here, but all right. So I'm sure you're going to do a much better job of graphics than I have here. I've got kind of limited capacity with my tool. All right, so we're going to make it a different color. And so we know from Contour Map Creator that darker blue is lower elevation. And as we get lighter, we're getting higher up in the landscape. So what I typically do is I'll start at the lowest point on the property. And that would be right here, right? So you'll have to excuse any squiggles, but basically what I do is I start to come up, and we know, I'm going to make that a little thicker. We know that water is going to move at a right angle to contour. So we have to keep that in mind as we're doing this. And if we start on this, we're kind of go up to our first contour. You can see there's a little bit of an angle here. So I'm going to assume that this is where we're headed. So we're kind of having to reverse engineer. So if this is the point on a contour that I know is a boundary, we have to try and figure out where that's coming from. And it looks like it's probably going this way. And then we're going to sort of terminate on the road here. Now that's not a very pretty line. Basically, that's going to run all the way down the road to the front of the property here. Now, if we go back up to that corner, and we're trying to define a bit more, this is all low, so there's no water. Water is not coming in this direction. And once we get to this corner, we can see that elevation starts to go up. And then you can see we got a road. So well, sorry about that. We've got a road here, so we are going to go along that. So we know all of the water that hits here is going to travel in this direction and influence our project site. I'm going to come down to this corner, and it looks like we'll go right along the edge of the road, which may be the property line might be set back slightly from that. But that would be our project site boundary. And then we have to add the basin, which would basically be everything inside of this. It's not showing up too well here. Try and make it a little thicker. So there you go. So you can see there's a little bit of land outside of that project site the project site boundary. All this land here could potentially influence. Right now, the next tricky part, and this is where it gets a little bit muddy, is we have a riparian area, and it looks like the water is heading in this direction. So one could assume that if water hit here, we have rainfall, water hits here, and it ends up in the creek, that is still going to pass through the site. So in some cases, and in Matt's case here, we may have to look a little bit further, even though we have roads that are constraining us, we may have to look a little bit further because we have a creek that's going under the road, right? We have I'm sure there's a big culvert there. So let us clear that. And we're just going to back up a little bit. And then you can see we have another road here. So we've made the space a little bit bigger. And you know what I'm going to do? I'm going to change this interval just for the moment and make it 5 meter, or sorry, 5 foot, just so we can see what's going on here. Basically, this creek is still, it's going to be flowing onto that project site, and we kind of have to back up and figure out where that influence ends. Oh. And I think I'll change this so it's going to be legible. It's a little bit better. There's the creek here. And you can see, actually, you can see the contours for the creek here. And you can see how we're gaining an elevation. And it looks like it's right there. You might have to do a little bit of hunting here to find it. Whenever we get contours looking like this, generally when they're going uphill, that is indication of drainage. So it looks like the creek is running through here and then down in this area. And then I kind of lose it. I don't know. Maybe it's over here now. And this is a little bit of the inaccuracy of this site. Yeah, I'm starting to lose sight of it, and obviously it gets reduced at some point. Let's say that we'll go back to where we can last see sign of it. Looks like it's up here. So you can see how tricky this might get. or does get. And this is even too much information for us to digest. But here's our project site way back over here. And there is an influence through that creek from lands far away, quite far away. It looks like it may sort of peter out here. I'm not sure. I don't know if Matt, if you have an idea where this might end up, but let's say it does end off here for some reason. I mean, the creeks do begin and end, of course. So in this case, what we'd have to do is start plotting on either side of the creek up to a road. So if we went way back to our project site, and I'm going to do something quite rough here, because this is, you can imagine this would take a little bit of effort to do totally accurately. I think we're a little bit away from that. There we go. I would say we're not up high enough on this side. So it looks like we're at the top of a ridge here. We're a hill. Same with here. So that's great. Now we have kind of an end point. So we'd have to go along and discover all of these spots that are not being inhibited by roads. And again, if we, let's just roughly, this is not completely accurate, but let's say that is our project site. There we go. So we do the same thing. We don't have as much contour data here, so a little bit trickier, but we know these are the low ends, right? So if we were heading uphill, I'll better do another color. So if we were heading uphill, and of course we're onto a roadway, but let's just continue, because that roadway, the water's not going to disappear into a storm system. And so we would end up here. Now that is not totally accurate. I'm being a little bit inhibited by the tools I use here. Okay, so, and then we would definitely bridge across. And because I have to move my screen, I'm going to lose all this information. But basically, we're going to be heading in a slightly more accurate manner up to this ridge, with the top of this hill. So in theory, all this water that falls on the project, that falls here, is going to head towards this creek. And then that creek is going to flow towards the project site. So I hope that makes sense. This is a more involved micro watershed. So thanks for that, Matt. It's always good to get a tricky one. We're going to also look at more of an urban site, which is, you know, very different process. This is much broader. So in this situation, you have a lot more, you have a higher ability to collect water that is coming off of the project site itself. So I'm sure that is something that one could witness through the winter months, the flow of this creek. And of course, if there was too much water in there, there could be a risk of a bit of flooding happening here. If we go clear that, and let's see here, we'll just move a little bit. So if we come in here a little bit closer, and then we go back to 2-foot contours. I think, yeah, those are 2-foot. So we can calculate pretty easily from this part of the creek up to the house. That's only 6 feet, right? So that would be, you know, definitely concerning. And concerning in the fact also that we've got, it
So
looks like, oh, go ahead,
I've
Matt.
checked the LiDAR data.
Oh, yeah.
The LiDAR data the contour map is very accurate compared to the LiDAR data available. The creek sits at roughly 518 feet of elevation all the way through that property. So it's dug itself a really deep trench.
Oh, wow. Oh, that's great. Well, that's a nice a bit of buffering for you. And so when you get a higher flow rates going through there, it's going to be able to contain it much better, right? Also, all this vegetation is going to enhance that ability and stabilize it. Do you have any erosion that's going on there, Matt? Do you see on the...
Not a lot. It's only a seasonal creek during the winter and spring months,
I see.
for the reasons that you already stated.
I see. Okay. So that's very interesting. So you wouldn't really be depending on that water going through there during the growing season, but during the winter it could actually be an asset that, you know, for all kinds of purposes, you might, you know, be allowed to do micro hydro. You could generate a little bit of power off of that. You may have rights to the water going through, so you could withdraw some, you could pump some out. There's all sorts of options, but you do really want to focus, you know, the whole drainage, rainwater harvesting thing goes together. So in the growing season, we want to generally hold and reuse water. And in the winter months, we want to make sure it doesn't threaten the land or the dwellings here. So did that help at all, Matt? I know we're if you have LiDAR data, then that would make it much easier to plot this. So if your data extends out and you have do you have like 2 or 5 foot contours to work with?
That was really helpful. And my only comment is that this contour map is pretty much neck and neck with the LiDAR data. So
Oh,
that's
wow.
other than where at the creek point there, it doesn't know that
Right.
the ravine is pretty deep,
Right.
but in all the open land, it's pretty accurate.
Well, that's interesting. Okay. Well, the nice thing about LiDAR is when you process that information using the right software, and it might be you know, QGIS or ArcGIS, you can tell the software to eliminate all foliage. So all you're doing is getting contour data off of the ground itself. Cool. So yeah, it's a great tool, and we certainly use it quite a bit. And generally speaking, the data is free to acquire. So you can definitely get a lot of information, provided you can operate the the software, and it is doable. It's just not very intuitive. So yeah, that was a tricky one. That's always the
What
exciting.
software do you recommend?
Oh, sorry, what was that?
What software do you recommend? Do you recommend a software for processing the LiDAR data?
Yeah, well, the what we use is called QGIS, and it's a open source software. So it's free. It's takes a little bit of you have to do a little bit of training on it. And there's lots of training resources now on the internet. So a lot of YouTube videos showing you some basics, but it does take a little bit of time to get used to. But it is a game changer for those leaving this class wanting to do more design work. It's a really powerful tool. And when you have that data, when you have that LiDAR data, you can project all sorts of things. You can ask it to do slope analysis. You can ask it to do basically what we're doing here. It will show us all of the drainage lines and basins within a site. And again, very, very powerful tools. And I know we have been we've been looking at properties outside of where we live, actually on the east coast of Canada. And I can go and grab LiDAR data from a hub in that province. And if we see something that looks interesting, we can actually get a very, very clear view of the topography and how water runs on and off of the site. So it's a very, very useful software to get to know. And again, it's called QGIS, and very easy to find on the web, and it's a free download. So, all right, well, let us,
Thank you.
yeah, no problem. Um, maybe we'll look at Hannah's site. Hannah, you're on the call here. Can you tell me whether this is I'm sorry, I don't remember your project site offhand. Is this an urban or a acreage site? Oh, maybe Hannah's not here. Um, yeah, I'm hoping to get an
I'm sorry,
urban.
I am here.
Oh, hi, Hannah. Yeah, just asking if your project site, is it an urban site? Like, is it within the city or
It,
is it?
it's rural.
Okay, we can take a look at that. Sure. And maybe what I'll do before we look at yours, I'll just do a very quick look at where I live or the community I live in. And we'll do a quick run through with the urban, because it is a different approach than these larger rural properties. So let us take a look at this. We'll just make it a little bigger here. Okay. So we're going to give it 2 contours and there we go. That is 2 for contours. Now let's just presume make a presumption that this is our project site boundary. All right. So it's the same, exact same process, similar but different. So we always start at the bottom. So here, based on what I'm seeing on these contours, their water that hits here is going in this direction, away from the project site. And then we can see the angles change a little bit here. And picking up a little bit of the neighbor. And then we're going to start to go uphill. Because that blue, based on the legend, and obviously the ocean or the water here is lower. And again, this is a little bit on the rough side, but you can see we're traveling uphill and then we hit a roadway. So when you're into urban or smaller properties, this road is going to be a constraint for you. Okay, so the bottom of our watershed boundaries there, and then we're going to start moving up, and you can see with these contours. And again, this is a little bit quick and rough, but we're going to run up here. So in this situation, that would be our boundary roughly, right? Just as a basic quick. And then that's great. That's the hard part, getting the boundary. And then we want to indicate where the basin is. And I won't show you all the graphics there, but we want to indicate that inside is the basin. So everything that falls within this area could potentially influence the project site. And then there may be some obvious water flow lines. So what do those look like? Well, they often are these sort of uphill. Yeah, I don't really see anything obvious here. Now, you may have enough knowledge of your project site that you just inherently know where you have some drainage basins. But if I was looking at this and I had to indicate something on here in terms of flow lines, you know, you could just make sure you're sort of at right angle to contour here. This is how the water's going to move. Okay. Not that last one. And this is actually going to go here, and then that's going to go there. So that's kind of a very quick example of an urban. And well, we've got a little bit of time here. Let's take a look at Hannah's site. So to do that, I'll have to reset this, and eventually the contour map creator won't let me do any more. Hopefully that's not now. There we go. Okay. Okay. Looks somewhat familiar. Is it right here, Hannah?
It's in between, well, it's in between Ptarmigan Trail and D Road. You can see D there. And it's the house that connects between the two. So just to the left, yep, right there, that house.
Okay, so if we put a boundary, is that kind of accurate for your project site boundary?
Yes, it goes all the way to the highway though.
Ah, okay. I don't think I can, no. Now, maybe what I'll want to do is just back out a little before I do that, because I can't change my view here. Okay. We have roads in the way though. Okay. All right. Sorry about that. We'll put that back and we'll go all the way to the highway.
Yeah, that's
It's
perfect.
a little too wide. All right. Now we just have to tell it what we want to do. And we'll ask it to give us 2-foot contours, and then we can just then we have to say get data. And that unfortunately moved the map a little. Uh-oh. Now I'm hooped. All right. We're just going to try and move it back. I think that is pretty close right there.
Mm-hmm.
Yeah. So you can see we're gaining elevation in this direction. Uh-oh. Okay. Ah, good. All right, we'll say it's here, and I'll probably just reduce this so it's a little easier to look at. There we go. So one thing we could do here is the same thing. We can start at the bottom. And so if we start at the bottom and we're going up the side of the property boundary, because we know that there's nothing that falls here is going to go back uphill. It's all going to head in that direction. Okay. And then we have that trail, which looks like is that a paved road, Hannah? May or may not be. Looks paved.
So
The
that it's a dirt road, but it has quite big ditches beside it.
Okay. Well, we'll assume that it's not going to interrupt flows from the upper to the lower part, but it probably will, eh? So if rain falls here and heads to that road, the odds are that water's going to head in this direction along the top side of it. Is that correct?
Yes.
Okay. So we'll just we'll head up in this direction. So in your case, the micro watershed goes right up this side based on the way these contours are looking. And we're along the bottom there, and we're going to come up, and then you can see them start to drift off here. And then we get to a roadway, which is going to be a constraint, and we're going to follow the inside curve of it just for the sake of this exercise. And now we have another road. Now, odds are you have pretty low rainfall where you are. There's probably ditching up here, and undoubtedly there'd be culverts sending water underneath. So let's assume that
There's those roads are pretty much just dirt roads that have no drainage.
Perfect. Well, perfect for this exercise anyways. So it looks like now we're going this way. And that would be that side. This is funny because it's curving us inward. Oops. and then it's going to head up beside it. Now we can't see the peak here yet, and when I go to move, I'm going to lose this boundary, but this would be roughly the boundary at this point. So any water hitting this part of property could potentially come down and influence yours. So I'm going to have to clear that, and I'm just going to back out a bit. Now this road up here, is this more of a major road that has the Z on it? Or are all these very similar?
Yes. I would say that Z and J are more like Ptarmigan Trail, where they're dirt roads that have ditches.
Okay. So the reality is where we have J, that may be a constraint, then the water may be diverted. Do you know if you have culverts that collect water and direct it underneath the road, or do you think these?
There's a few of them, but not a ton.
Okay. So it looks like our micro watershed would end up terminating up here. And that this road we'll say is going to be a constraint. So it's again, because I had to change position, I've lost that, but that curve would continue up to this high point here, and then the other side would come down here. So you'd have to, this is not accurate by any means, but accurate, but not, you need a little bit of higher resolution to do it. And then of course, with this software, it's tricky if we're trying to make any changes when we go to move here. So there we are. There's our project site. And yeah, I would say this would be the top of your micro watershed. So if I was to draw a very quick boundary again. And here we go, something like that. And then we're sort of coming up here. And then it's going to curve up in this direction. And then there will be basically a peak up here where that road interrupts. And then we'd have to do the same here. So part of the boundary is the bottom of the property. And oh, having trouble drawing straight lines today. It's not as easy as it looks. Well, we'll pretend that's on the project site boundary, and it looks somewhat like that, something like that. You know, that's very rough, and if you had a little bit more time to play with it, we could get it looking much more accurate. But that is, in a nutshell, what that's going to look like. And then, of course, we've got to indicate the basin with that's inside the boundary. So we would go all the way around with that. And then we would want to indicate some water flows. And again, those are just basically right angle to contour. Of that sort of thing. The software I use will actually do this for me, which is kind of nice. But when you see a contour, the water is always going to move 90 degrees to that. It's always going to behave that way. It does not move this way. All right. So hopefully that has taken a little bit of the mystery out of this. Does anybody have any questions at all they want to ask while we're all on the call right now? I know I spent a bit of time on these, but it does take a little bit of time, and some of the micro watersheds are much easier. Let me give you another example here. Let's just say we go to Portland. I'm just going to go into somewhere random. Yeah, so this is a good example. Let's say that this is our project site here. And we know for sure that we are not going to pick up anything outside of this area, just because of these roadways. We have curbs, we have catch basins. If we go and ask, now I have to move the map, which is gonna just clear that. So 3214 is our we have to keep resetting this. Oh, it's on 5. All right. I didn't reset the software or the website, so it may not do this for me, but we'll see. No, it's not going to do it for me. That's one thing about this. You have to go through this each time. All right, try again. Here, different locations, similar but different. So we'll make this our project site, and we will ask it to, we could probably safely get away with 1-foot contours here and still see everything. It's always nice when it moves it. So here we are. And you can see we've got a high point over here. So if we were trying to figure out micro watershed in this sort of situation, it would be very different. And we would start at the bottom. So that would be, oh, I better have another color. So we would be here. Oh gosh. Good thing I have a computer to help me out. So we would be, here's the low point. We would be running basically right up this side. It's very, very straight. And then we'd be at the top of that hill here. Now coming up this side, it's pretty straight too. And then it starts to curve over. So that, in a very crude way, would be the micro watershed in this kind of a situation. So everything inside of this, that water hitting on this inside area potentially could influence our project site. It doesn't mean it will, it just could potentially. So that's typical of what we'll see in urban locations. They're very they're confined by pavement and drainage systems that you see in city setting, whereas more urban areas are obviously going to be influenced by primary roads. But as Hannah said, she has some dirt roads with no drainage, so we can pretty much ignore that as a constraint. And yeah, so hopefully that is just makes that a little bit clearer for everybody. How's everybody feeling about that? Do we have any questions at all? So again, the one thing I would consider here is when you go through this exercise, what is the takeaway, right? So with all of that water potentially influencing your project site, what can you do to not only perhaps protect the site during the winter months, but to optimize the water use during the summer? So even though that's not really part of this exercise, it would be something that I would encourage. And just before we go here, I'm just going to show you one thing. And this is basically a deliverable, sort of deliverable that we would provide our clients. And this is basically what we call a water layer, where this is the first design layer we look at on a project. And how we approach this is we're looking at catchment off of roof areas as well as hardscape, and how can we best utilize it. And in this case, we're sending it into a rain garden. Even though this client had a metal roof, there was no desire on their part to capture and reuse it in cisterns, but to redirect it into the landscape made a lot of sense. And you can see with the topography here, the slope is in that direction. And then with the rain garden, once it hits capacity, water can go downhill to a roadside ditch, which is very convenient. But here's our micro watershed, and there's very faint contour lines here, but you can see the size of the, let me just try and zoom in a little bit here. You can see the size of the project site versus the catchment. And we do a little runoff volume here. We've got the main residence. So from neighboring properties is, over 30,000 square meters. So we use square meters. Well, I can use both square meters or square feet. And I've only given it a coefficient factor of 0.1. So I'm assuming only 10% of that water could potentially run off because it's all forested here. This is a park. but even with that, there's over 3 million liters per year that could potentially fall or influence this site. And sure enough, when we've been working there, we have seen groundwater go up. And let me see if I got a picture to show you that, and then we'll call her a day here. Just stop share here. And I'll go to my photos. So there you go. That is on this project site. We put some retaining in, and uphill, you can see that's uphill. So we have water heading up on the surface, although we haven't witnessed water running on the surface, but the groundwater in the winter time was, right there. So there was an error made in the drainage that was put in, and it got rectified. But this was just before Christmas. We got a call that there was a problem, and it's always then we had to try and alleviate that problem. You can see my wife Angela here, not too impressed. We're taking a short break, and so we relieved the pressure. Everything worked out just great. There was no flooding, but this is what the mason had to do. He had to remove all of this. He had to tear down the wall, but in the end, we got it all rebuilt, and we actually modified how we were going to deal with these little plantings. So we ended up putting a little bit of elevation here, and what you can't see is at the very bottom we have a drainage basin set up that will, once the groundwater starts to creep up again, the water goes through a conduit that's here and it's going into the rain garden. So it all gets used, but yeah, that was I guess that's one of the things I wanted to just point out here is identifying these potential challenges and trying to utilize as best you can within your design, right? So the rain garden being one of them, and it's a fabulous little feature. I don't know if I have a really good picture of it today, but let's see if I do. And we actually ran into some challenges with that. When we were building it, we hit a clay layer, which wasn't a normal part of the soil profile. And we elected to put a drain in the bottom of that, just to give the homeowner ability to divert water if they wish to. And then we put a clean out at the end. So this is maintainable, and there's a little valve at the very end of it so that it can be opened or closed. These are very rough images here. Here's another little tip for you guys. We scrape this area to prep it for planting, but we hold on to all that turf and soil and reapply it. And then we put topsoil over that. We flip the turf upside down, but we applied topsoil. And so we're reusing that resource, which is great. Just try and find a picture of don't have too many after images of that rain garden. It turned out really well. But that's kind of what it looked like. You can see there's an overflow here. So if the water, we have water flooding in here to 6 inches. And when it gets above that, it goes into this little catch basin. And then that water heads to a roadside ditch. And there's also a built-in, if for some reason this gets plugged, I have a little armored overflow here, so water will get out of that bed. And then this rain garden benefits all these plants, as well as this planting here that's downhill. So I really like rain gardens, even in larger properties, but yeah, so it's a little bit of a long-winded session today. If for some reason anybody gets stuck during the week and they just can't figure out how to move forward, please don't hesitate to drop me a note, and be happy to walk through the process again with you. Just get a link I'm going to put in the chat here. There we go. So there's a link. If you do get stuck, you need a little bit of help, click on that link. You can book a short meeting with me, and we can go through your project and figure it out. But hopefully today's meeting has helped to take any of the mystery out of the whole process. And yeah, so if nobody has any questions, I think what I will do is call it a day. And again, thank you all very much for being part of the meeting. So you take care, and thank you very much for, again, joining me, and have a great week. Look forward to seeing your assignments when you get it done. Then, of course, afterwards, we're going to have a short break, and then we'll be back at her with a Q&A for lesson number 6, which is much easier than lesson 5. So yeah, anyhow, you all take care. We'll talk to you soon.